So now let us go for second part of derivative of inverse trigonometric function. In last video we have seen the derivative of sin inverse x and cos inverse x using the formula for derivative of inverse function, that is dy by dx is equal to 1 upon dx by dy, and we have obtained derivative of sin inverse x is 1 upon a root of 1 minus x square, and derivative of cos inverse x is minus 1 upon a root of 1 minus x square. So now in this video we'll go for derivative of tan inverse x and cot inverse. So let us go for that. So we consider if y is equal to tan inverse x, x belongs to R, and minus pi by 2 less than y less than pi by 2, because for this condition only tan inverse x exists. For this condition x is equal to tan y is 1 1 and on 2, so its inverse exists. So this is the must condition for existence of this inverse function, and if the function is in this form with these conditions, then only its derivative dy by dx will be 1 upon 1 plus x square. So we'll go for the proof. Proof is very similar to the proof of previous two, that is derivative of sin inverse x and cos inverse x. So we consider the given function y is equal to tan inverse x with the condition x belongs to R, it is set of real numbers minus infinity to plus infinity, but y should be, there is one printing mistake again, y should be there in between minus pi by 2 to plus pi by 2. Then x is equal to tan y. So we are getting x is equal to tan y there. And so dx by dy is equal to sec square of y. It is the derivative of tan y with respect to y. Now we have the derivative of inverse function. We have the formula dy by dx is equal to 1 upon dx by dy.
So now we use equation 3 in 4, that is the value of dx by dy in equation 4. Dx by dy is sec square y. So using equation 3 in 4 we get, see, LHS is dy by dx is equal to RHS 1 upon dx by dy, and the value of dx by dy from equation 3 is sec square of y. So this is the answer of the derivative, but as we have discussed previously, we have to go for the simplification. We have to convert sec square y or sec y in form of tan y. So for that we'll use the identity. What is that? 1 plus tan square y is equal to sec square y. So replace sec square y by 1 plus tan square y. And now the next step is very simple, because tan y is x from equation 2. So using it, now we are getting dy by dx is equal to 1 upon x square. And so we got the answer in form of x now. Thus we are getting dy by dx of tan inverse x is equal to 1 upon 1 plus x square. So this is the formula for derivative of tan inverse x.
So this is what we have obtained is derivative of tan inverse x. Now derivative of cot inverse x is very similar to it. So directly I will show the proof of it. So we'll go for derivative of cot inverse x. Y is equal to cot inverse x. X belongs to R, and here small change for y there. In previous step it was our previous derivation for tan inverse x, it was minus pi by 2 to plus pi by 2. Here it is 0 to pi. Then dy by dx is only differences of minus and minus 1 upon 1 plus x square. So proof is, let y is equal to cot inverse x, we have called it as 1. The condition is same, x belongs to R and 0 is less than y is less than pi. Then from 1 we are getting x is equal to cot y by definition of inverse function. We'll go for the derivative of x with respect to y, dx by dy. Derivative of cot y is minus cosec square y with respect to y. This is the equation 3, and we have the formula for derivative of inverse function. It is dy by dx is equal to 1 upon dx by dy we have called this equation 4. Already we have calculated the value of dx by dy in equation 3. So now we'll use equation 3 in 4. So using 3 in 4, we get dy by dx is equal to 1 upon minus cosec square of y. 1 upon cosec is sine. One may write it as minus sine square, but better option is there. Cosec square y can be written as 1 plus cot square y. This is by trigonometric identity, and cot y is equal to x from equation 2. So it is very simple way to simplify it. Dy by dx is equal to 1 upon minus 1 plus x square, and so derivative of cot inverse x with respect to x is minus 1 upon 1 plus x square, and this is the answer. This is the derivation for derivative of cot inverse x. Again, the derivative of tan inverse x and cot inverse x has only difference of minus sign. So the proofs are very simple. They may be asked in board examination. So if proof is asked, you can easily write the proof, and you must remember the formula, because after the next video we are going to solve the examples on derivative of trigonometric functions. So now we are going to stop this video here only. In the next video we'll go for derivative of sec inverse x and cosec inverse x, which required some restrictions there. So we'll discuss those in the next video. So we'll stop here.